Let T be the triangle in the coordinate plane with vertices 0, 0, 4, 0, and 0, 3. Consider the following 5 isometries. Rigid transformations of the plane. Rotations of 90 degrees, 180 degrees, and 270 degrees, counterclockwise around the origin. Reflection across the x-axis, and reflection across the y-axis. How many of the 125 sequences of 3 of these transformations, not necessarily distinct, will return T to its original position? For example, a 180-degree rotation followed by a reflection across the x-axis, followed by a reflection across the y-axis, will return T to its original position. But a 90-degree rotation followed by a reflection across the x-axis, followed by another reflection across the x-axis will not return T to its original position. There are 5 options here, A, B, C, D, E. And essentially, what we want to do is casework. So, what's case 1 then? Case 1 is where there are no reflections, because this is just like the most simple case. As long as our rotation angles add up to a multiple of 360 degrees, we're fine. So how do you make sure they add up to 360? Well, we can first intuitively think of 90, 90, and 180 degree rotations. So this is one case, and there are 3 ways to achieve this case. And what about another case, for example, so we can't find any more after some after some experimenting, we can't find any more 360 degree summed rotations. So you try to find 720 degree rotation sums. Realize that you can do 270 degrees, 270 degrees, and 180 degrees. There are 3 ways to do this. So this sums to 720 degrees. There are another 3 ways to do this. Now, how do we know if there are any more other cases? Well, realize that if you want the 3-step process A, B, C to have an angle sum of 360 or a multiple of 360, since there's no 0 degree or 360 degree in this list of selections, A plus B must not be a multiple of 360 degrees. So if we try any other combination, for example, 90 degrees and 270 degrees, this sums to 360. 180 will also sum to 360, etc. So if we keep trying, we know that there's no more cases. Second case is where there's 1 reflection. But does this case actually work? Well, no. Why? Because if we start with a triangle like this, so let's say this is our triangle, and so let me just draw this so that the different side ends are more obvious. We reflect this across the y-axis, then this is what we get. Now try rotating this back to its original position. It just won't work if you rotate via the origin. So it's gonna go like here, but that's not. So what you imagine is it's gonna flip 180 back to here, but that's not rotation. That's reflection. If you rotate it 90 degrees counterclockwise, then this is what will happen. What about 180 degrees counterclockwise? Wait, that's clockwise. Okay, if you rotate 90 degrees counterclockwise, this is what will happen. What about 180 degrees counterclockwise? Well, this is what will happen. What about 270 degrees counterclockwise? Well, this is what will happen. So notice no matter how hard you rotate, you can never get back to the original triangle. Now, what about in the case where we have a reflection across the x-axis? So this is what we get, the blue triangle over here. Okay, so this means that when we try to rotate via the origin, if we rotate 90 degrees counterclockwise, then this is what we get. What about 180 degrees counterclockwise? Then basically we get this triangle. What about, so this is not the same triangle. The side lengths are really different here. One is 3, one is 4. What about 270 degrees counterclockwise? Well, this is what happens. So we'll never get back to the original triangle. So 1 reflection does not work. So what about having 2 reflections? So instead of 1 reflection, we change it to 2 reflections. Now this will work. Why? Because firstly, you can reflect back and forth. For example, I can reflect from, I can reflect across the x-axis, and then I can reflect across the y-axis. So this is what I get after I reflect across the x-axis and the y-axis. Notice that when I rotate this around the origin, if I rotate it 90 degrees counterclockwise, then I get this triangle over here. If I rotate 180 degrees counterclockwise, I get back to my original position. So this actually works. So one way of doing this 2 reflection case is we can reflect across the x-axis, y-axis, and 180 degree rotation. So how much ways are there to do this? There are 6 ways to do this. Now, are there any more ways we can do so? Well, no, because if you reflect across the x-axis, then reflect back across the x-axis, there's no 0 degree or 360 degree rotation directly. So there's no one-step rotation that works, and the y-axis will be the same case. So that won't work either. So what about 3 reflections? For having 3 reflections, what happens is just so 2 of the reflections are gonna cancel out, and we're gonna result in 1 reflection, which just won't work out if you try to draw the graph on your own. So the answer is just gonna be 6 plus 6. So it's 3 plus 3 plus 6, which is just 12. So that answer is A. Thanks for watching.